Hello, hello, hello. Today is Sunday, January 25, 2026. It is snowing here, but had nothing to do with the solutions of problem 247 by Eugen. We have a piece of wood that is floating in water. You see that on the left, that is the equilibrium position. So the force mg, mass of the block down, is equal to the upwards force, I call that the Archimedes force, which is due to the water that is displaced. And he finds now that in equilibrium position, he has to look up the density of the wood. In equilibrium position, the value y0 is about 7.5 centimeters. We now push the block further into the water by a distance y. And then he calculates now the net force upwards. The force down remains mg, but the force upwards goes up because of this extra distance y. And the net force upwards is ma. My double dot. There you get the differential equation. In mass terms, he writes, we have a second order linear homogeneous differential equation. If you watch lecture 10 of 801, I cover that in great detail. He shows the differential equation, and then we find the period of oscillations will be 0.55 seconds. Luckily, many people have that. I would say at least 20. It's an easy problem. He adds a few comments. The period is independent of how much we push the block in the water initially. So the period is independent of this y. He also, you see here, the period is independent of y. It does depend on densities. If you place the block in honey, then rho is higher, and then the period becomes 0.46 seconds. If the block would have been expanded in polyestyrene, which has a density of 40 kilograms per cubic meter, then the period would have been 0.13 seconds. And here you see Walter Lewin in the lecture 801. This demo that you see here has nothing to do with this problem. But it's very kind of Eugen that he shows this, because what you see here, that is key. That equation, x double dot plus k over m times x is 0, that means that x is a simple harmonic motion. And that's exactly what we deal with here. So he shows you this picture not to see me with my student, with this demo, but he shows you this because of this equation. Thank you, Eugen. We will have snow for 24 hours, maybe even for 2 days. I hope I will survive that. As I mentioned earlier, there are quite a few solutions. Roughly, I would say about 20-25 correct solutions. If you can't do the problem, watch my problem 10 of 801. If you then can still not do it, well, then there is not much more I can do for you.